In this video, I'm going to talk about friction wheels. As you can see in the image, friction wheels is a set of two wheels located one next to the other. As you can see here, one wheel is going to be connected, it's going to be coupled to an engine or motor. So it's going to be called the driver. Okay. So in this case, wheel 1 is going to be the driver because you're not seeing this in this image, but has to be connected, coupled to a motor or engine. So this wheel is going to communicate motion or transmit the power from the engine to the driver, to the driven wheel. So we have the driver and we have the driven. So the driven is not connected to the engine, but because they are touching each other, because they are in contact, they are going to transmit the motion. Another thing you have to consider is, in this case, you can see here an arrow. So friction, the first wheel here, this one, is rotating clockwise. Okay, imagine you have a clock. The direction of the clock, of the needles, is this one. Okay, and the driven wheel is rotating the opposite direction, and we call this direction counterclockwise. Okay, clockwise, counterclockwise. Okay, so imagine that you want to transmit the motion here, but you don't want to change the direction of the second wheel. You will have to use as you can see in the image, an idle wheel here. Here there's an idle wheel, so the engine will be connected, coupled to the first wheel, to the driver wheel. So it's going to transmit the motion to this idle wheel. So the idle wheel is counterclockwise, and the driven is going to change again the direction of this movement. So the driven wheel is rotating clockwise, the same as the driver. Okay, so the only purpose of the idle wheel is to change the direction. Okay, now the driver and the driven wheel are rotating in the same direction. Okay, so as you can see in this image here, depending on the radius, the diameter, we can increase the speed, keep the same speed, or we can reduce the speed. In this image, the red wheel is going to be the driver wheel. Okay, so if the driver wheel, the radius of the driver wheel is bigger than the radius of the driven wheel, we're going to increase the speed. Okay, here, if both wheels they have the same radius, the same diameter, so the speed is not going to change. We're going to keep the same speed. And here, if the driver wheel, the red one, the red wheels, they are the driver wheels. So if the driver wheel has a smaller radius than the driven wheel, you are going to reduce the speed. Okay, so I think we're ready to do the first exercise. Okay, so let me here. Okay, so imagine we have an exercise like this. It says, in a friction wheel transmission system, one wheel with a diameter of 60 centimeters is coupled to an engine and rotates at 20 revolutions per minute. The other wheel has a diameter of 15 centimeters. So the first thing you have to do is to draw the system you have here. So we have two wheels. One is going to be bigger than the other one. It says that it's a friction wheel, so they have to be in contact. and I know one wheel has a, it says diameter radius, diameter of 60 centimeters connected to another one with a diameter of 15 centimeters. Okay, I have to identify which one is the driver wheel, and which one is the driven wheel. So it says in the exercise that the wheel with a diameter of 60 centimeters coupled to an engine. So this one is going to be, it's like you have here a motor, an engine here, producing motion. So in the axis here is this wheel is going to be coupled. So the motion here is, so this is going to be my driver wheel. So this is going to be my driven wheel. Okay. So first thing we have to calculate is the transmission ratio. What is the transmission ratio? The transmission ratio is the relation between the speed of the rotational speed of the driver divided by the rotational speed of the driven. In some textbooks, they say that it's 1 divided by 2, but imagine that the motor here is connected to this wheel, so it's not so clear what is the first and what is the second. So it's better to have the driver divided by the driven. So transmission ratio, I have I have in the exercise here, it says that the bigger one, the 60 centimeter, is coupled and rotates at 20 revolutions per minute. So I know here the rotational speed here is 20 revolutions per minute. So this is the driver. Okay. So I know this one, but I don't know this. So the first part, I'm not able to do it, to solve it right now. So firstly, I have to calculate this. How can I calculate this? Because in these systems, there's a relation between the speed and the radius or diameter. So you can say that here okay, and now it doesn't matter if you put here 1 or 2, because I'm going to consider 1 as the driver, but you could consider the other way around. So imagine in this I have 4 unknowns, so I have to identify what I have here. Imagine I'm going to say that it is my 1 and this is my second. Okay, so if I know the product of the rotational speed of the first wheel times the diameter of that wheel should be equal to the rotational speed of the second times the diameter of the second wheel. So here, what is the rotational speed of the first wheel here? 20 revolutions per minute. If you multiply this by 60, okay, you have to check if you have the same units here. Okay, I have centimeters, so I don't have any problem. So it should be equal to the speed of the second wheel here. That is my unknown. I don't know that, so that's what I have to ask. I guess here in the third part, I have to calculate this. In fact, I need this to calculate the first one, so I should start for the third part. So the diameter of the driven wheel is 15. Okay. Now you have to solve this equation for the unknown here. So x is equal 20 times 60 divided by 15, and here this is, if you do the calculations, if I'm not wrong, it should be 80 units revolutions per minute. Okay, so I've calculated here the speed of the 15 centimeters diameter wheel. Okay, so here the second wheel rotates at 80. Now I'm ready to calculate the transmission ratio here. So I is going to be the driver wheel here, 20 divided by 80. So I do the calculation now. I think it's that. This is the A, this is the C, and now it says you have to calculate the direction of rotation of the second wheel, the 15 centimeters diameter wheel, knowing that the first one wheels rotate clockwise. Clockwise is, so they are saying that it's rotating clockwise. Clockwise. So as they are in contact, it's going this direction, so it's going to be the second one is going to be, so the second part is rotating counterclockwise. Okay, that's all.